business and community. Forward, it's the way to go. Driving change for a better world. Forward, together you and me. Advancing business and communities. Lead on with our ABCs. Driving change for a better world. Lead on, together you and me. Advancing business and communities. History is what we shape today. Staying true to the Aboitis way. A nation rising high. Embracing change. We walk, we run, we fly. The difference we can make. And the courage that it takes. With values strong to guide us through. Make better lives with each step moving. Forward, it's the way to go. Driving change for a better world. Forward, together you and me. Advancing business and community. Forward, it's the way to go. Driving change for a better world. Forward, together you and me. Advancing business and communities. Lead on with our ABCs. Driving change for a better world. Lead on, together you and me. Advancing business and communities. History is what we shape today. Staying true to the Aboitis way. A nation rising high. Embracing change. We walk, we run, we fly. The difference we can make. And the courage that it takes. With values strong to guide us through. Make better lives with each step moving. Forward, it's the way to go. Driving change for a better world. Forward, together you and me. Advancing business and community. Forward, it's the way to go. Driving change for a better world. Forward, together you and me. Advancing business and communities. Lead on with our ABCs. Driving change for a better world. Lead on, together you and me. Advancing business and communities. History is what we shape today. Staying true to the Aboitis way. A nation rising high. Embracing change. We walk, we run, we fly. The difference we can make. And the courage that it takes. With values strong to guide us through. Make better lives with each step moving. Forward, it's the way to go. Driving change for a better world. Forward, together you and communities. History is what we shape today, staying true to the Aboitis way. A nation rising high, embracing change. We walk, we run, we fly. The difference we can make, and the courage that it takes. With values strong to guide us through, make better lives with each step moving forward. It's the way to go, driving change for a better world. Forward, together you and me, advancing business and community. Forward, it's the way to go, driving change for a better world. Forward, together you and me, advancing business and communities. Lead on with our ABCs, driving change for a better world. Lead on, together you and me, advancing business and communities. History is what we shape today, staying true to the Aboitis way. A nation rising high, embracing change. We walk, we run, we fly. The difference we can make, and the courage that it takes. With values strong to guide us through, make better lives with each step moving forward. It's the way to go, driving change for a better world. Forward, together you and me, advancing business and community. Forward, it's the way to go, driving change for a better world. Forward, together you and me, advancing business and communities. Lead on with our ABCs, driving change for a better world. Lead on, together you and me, advancing business and communities. History is what we shape today, staying true to the Aboitis way. A nation rising high, embracing change. We walk, we run, we fly. The difference we can make, and the courage that it takes. With values strong to guide us through, make better lives with each step moving forward. It's the way to go, driving change for a better world. Forward, together you and me, advancing business and community. Forward, it's the way to go, driving change for a better world. Forward, together you and me, advancing business and communities. Lead on with our ABCs, driving change for a better communities. History is what we shape today, staying true to the Aboitis way. A nation rising high, embracing change. We walk, we run, we fly. The difference we can make, and the courage that it takes. With values strong to guide us through, make better lives with each step moving forward. It's the way to go, driving change for a better world. Forward, together you and me, advancing business and community. Forward, it's the way to go, driving change.
Maayong hapon, sorry. Okay, that's the energy ko doon. Maayong hapon, DSI, and welcome to Project Arkanghel Technical Roadshow. So, I hope you are all excited as I am here to be today. By the way, I'm Shen. So, I'm part of the Project Arkanghel team, and I will be one of your hosts for today's event. So, before we get started, of course, we would like to extend our welcome to each and every one of you, whether you travel far or just here at site or joining us virtually via live stream. We are thrilled and happy to have you here this afternoon. So, just a recap, it's been like 8 months since, is it right? 8 months, 6 months, 7 to be exact, since we kickstart the project. So it's really like a few months ago, and we are here right now to provide like first-hand experience of what the project is all about, how the system looks like, for you to know what's coming for this coming year. So with that, first I would like to appreciate and acknowledge the presence of our leaders. You are very supportive, and we truly appreciate your presence today. We have, of course, our regional COO, John Dean. Okay, we also have our Vice President for HR. We have Sir Law. Yeah, all right. And then we also have, of course, our facility head, Sir Abe. Thank you so much. All right. And then, of course, we have our managers. I can see Ganesh, even he's sitting at the back. All right, thank you. Of course, we have Mr. Ron Freely. Okay, thank you so much. We have also Sir Sam, partner, right? Co-host every time. All right, all right. Did I miss someone back? Okay. All right. So, without further ado, let's dive right in. All right. So, please join me in welcoming our first speaker. Okay, let's give a big hand to our program manager, Matthew Beckett, for the opening remarks.
Is it working? Okay, my hapon. Okay, I'll just introduce myself for those who have not met me yet. My name's Matthew Beckett, and I'm the program manager for Project Arkanghel. So, firstly, thank you everyone for taking time out of your busy schedules to come and be part of this technical roadshow. It's really important for you to participate, for you to interact with the board, and to hear in more detail from the project managers on what's actually going on with the work streams and how it's going to benefit us in the way we work today. So we hear so much about Project Archangel, and you've probably heard things like artificial intelligence, digital twins, smart power plant. But firstly, I want to dispel the myth that this is going to replace people's jobs. It isn't, but it is going to change the way we do work, and it's going to provide us a lot more information to make smarter decisions and spend less time wasting our time gathering information, gathering data. So Today's going to give you the opportunity to listen, learn, and ask as many questions as you want. There's technical leads, there's project managers. If they can't answer the question, then nobody can. So please make the most of it, ask as many questions as you want, and enjoy it is the biggest message. So just a bit of background. So I've spent probably the past 34 years in thermal power plants, and I started off as an apprentice mechanic. So I was a fitter originally, and then after working on the tools for about 6 or 8 years, I did an engineering degree. I went in and I was the boiler engineer for a while. Then I was balance of plant engineer for a few years. Then I spent a few years as the turbine engineer. Then I moved on to the Holy Grail, which was shift operations. And I was in the control room for a while doing permits, and then control room supervisor, all in thermal, maintenance manager, facility head. Then moved over to Australia and did a similar project for a 6,000 megawatt fleet of assets. So I'm fortunate enough to have been in all the roles that use all these tools. And I've seen firsthand how they changed my life and how they made my life a lot easier. And that's why I want to give you the background of where I've come from and where it relates to the way of working. So if you want to just put on to the next slide. So it's broken up into a number of different work streams. Now, work stream 0 is really the heartbeat of the system. It's where all the data comes back and integrates, and you'll hear more about that from Mix. But say, for example, the digital twin. So when I was a boiler engineer, we would get asked, how long have you got left on your life of your asset? What inspections do you need to do during your outages? How much scaffold do you need at the next outage? When's your next boiler tube leak coming? And we would used to have to go through and we'd do all the REM life calculations, we'd get all the data, we'd get all the ultrasonic thickness testing, try and look at extrapolating it out. And it was very, very manual, took us a lot of time. What the boiler digital twin does is uses computational fluid dynamics and finite element analysis to give us a real-time health and picture of our boiler. So it will allow us to plan our inspections better, understand how long we've got left on our boiler, look at where we should be inspecting during outages. So for a boiler or mechanical engineer or even operations, this is an absolute critical piece of equipment for us, is a digital twin. Now, if you look at predictive analytics, when I started, there was never any predictive analytics. What would happen is the plant would fail, and then we'd go back through all the information and all the data and go, the temperature was going up by half a degree a day. And the lube oil differential pressure was going up as well. Something was going wrong there, but it was always retrospectively. Whereas the predictive analytics now takes all this information, it notices these small changes that you wouldn't notice if you're an operator and you're busy operating the plant. And you wouldn't notice it as a reliability engineer because it's just going very, very slowly. But this thing can pick up patterns using pattern recognition and give you that early warning detection to say, hey, something's happening. Might not happen now, but it might happen in 3 months or 6 months. So that's really powerful for us. It gives us a massive competitive advantage and improves our availability. The unified health system. So I used to spend weeks and weeks gathering information for a health report, and I'd go through Maximo and I'd dig out everything I could to put it all together, like RCAs, all the temperatures, pressures. Now we've got a unified health management system, which has got all of the systems with all of the health, and you can drill down into it and see what's contributing to something that's not healthy, and proactively take action rather than spending all your time gathering the data to do a report but not acting on the report. Workstream 4. Now this is a really interesting one. So asset information management systems. This allows us to use the 3D plant to navigate to pieces of equipment, and from a single point in a few clicks get things like maintenance procedures, operations procedures, check sheets, all the asset information that you need, which traditionally would have taken hours, if not days, to gather, to put together for scoping exercises. And then with operator rounds, I remember doing operator rounds ages ago. I remember going up to level 4 on the boiler, taking a reading, and then it'd send me down to level 2, and I'd take a reading, then back to level 8 and take a reading. These smart operator rounds now, whereas before I would fill it out on a piece of paper and it would just either go in the drawer and no one would look at it again. This allows you to collect all the information on a tablet. It's been plotted in the most efficient way. So if you need to get reading 1 there, reading 2 there, it's been walked out and thought about. And all that information that goes into smart operator rounds from them important operator tours that you do on a daily basis feeds back into the health system and the early and the alert detection and the digital twin. So you can see it's extremely powerful. But what's important is it's not going to be perfect straight away. It's going to take you to keep an open mind and continuous improvement. If you find an error on the system, it's likely an error on our data, so it needs fixing and moving on. So where we're up to now, if you just go on to the next slide. So by the beginning of Q1 2025, we'll have Unit 1 boiler digital twin at TSI, 144 models on predictive analytics across boilers, turbines, fans, and balance of plant. We've done 10 models at TVI, Unit 2 turbine, the unified health system on 39 systems at TSI and 6 systems at TVI, and the asset information management system on Unit 1 boiler and fans at TSI and Unit 2 steam turbine. Again, same with the 3D virtual plant. And the smart operator rounds have been pretty much delivered now for TSI and TVI. There's still a little bit more work to do. Then after that, it sees us going on to complete TVI and the remainder of TSI, with us then with a view to go on to GMEC, GMPD, and continue this program because of the benefits that it gives us. So now getting into the technical details where you can ask hard questions, I'm going to pass over to the first technical guru. Welcome, Migs.
Hello, thanks, Matt. I'm Mix. I'm the workstream lead for workstream 0. So I'm under IT and data management team. So under the team of Noel. Ay, sorry.
Okay. Yeah. All right. So before Migs start the for Zone Zero or data management, let me provide you the instruction for our mini game. So we have two groups today. This is the green team. Can you see your leaflets? You're holding your leaflets, the A, B, C, D. And this is the blue team. Okay? So we would like to ensure that you'll be listening to each and our speakers today. So we have a mini competition. So the green and the blue, so each team, you can select your four main members. You can change your members every time that we have in each and every rounds. There will be two questions on each round, each work stream presentation. So we have flag. Ayan. So we'll be at the end of presentation, like after MIGS, there will be two questions. So you'll be selecting your final answer. Your answer will be holding the human letter will be holding the letters for your final answer and get the flag. And of course, the team with the most points will be our winner. We have a group prizes, of course, for the group winner. Okay, are you ready? Green team! Okay. How about the blue team? Alright, okay. Alright, so without further ado, let me reintroduce our next speaker for the Workzone Zero, Miguel Cabral.
Okay, hello. Okay, take two. So I'm Mix Cabral. Uh, I'm from IT and data management team under Noel Liwanag. And so national scope. Okay, for Project Arkanghel, my project is what we call, or my work stream is what we call work stream 0. Its responsibility or its concern is on data and system architecture. Next slide, please. Sige. Next slide. Okay. So quick overview. Quick overview. So what really is data and system architecture? It's the foundational work for for all our solutions. So all of the solutions of the other work streams are all running on software. And what we do in Workstream Zero is we have to make sure that we have an infrastructure. So this means the servers and also the data that will serve as input to the other work streams, and the servers where the software will run are ready. So that's the main responsibility of Workstream Zero, that we have that digital infrastructure. Uh, Aside from that, part of our responsibility also is to make sure that our data is ready not just for the current phase but for succeeding phases. So how do we make it sustainable? We're part of our work stream is to introduce what we call data governance. So it would be a new practice, new capability for TBG that we will start to roll out in the succeeding months. Uh, I think that's really what we do for Workstream Zero. Okay, next slide, please. All right. So what are we building? This is the diagram that Repco, our partner in building the solution, has been showing us. So we can think of it as three levels in the solution. So everything starts with data and how the data, how all of those data sources are interconnected. And then from there, we'll go to the analytic layer. So once we have the data coming from various sources, we can now come up with our predictive analytics or health policies, asset health policies, the boiler digital twin. So those data will serve as input to those analytical software. And last level is, or last layer of the solution is the visualization. Now we have to be able to make sense of the analytics in or relate it into a day-to-day operations. And usually the way we do that is we visualize it. So there are dashboards to be presented. There's a virtual model like this, and also a digital replica of the twin, or a digital replica of the boiler. So that's the digital twin. Okay. Now let's deep dive a bit into what data does it take for us to build a solution like this. Next slide, please. Okay. So it might be a bit small, but the layer below, the gray ones, so our workstream zero, is responsible for ensuring that all the data on the gray layer below are ready. So, for example, we have data coming from Box, the engineering documents. We have data coming from Maximo, information on the asset. We also get incident information from IRS. So this will help troubleshooting failures that are being reported by the system. We're getting laboratory test result right now in spreadsheets, even maintenance data, inspection data, but later on in workstream 5 in rounds, there's an effort to digitize them. Uh, we're also getting online data from our historian. So currently it's in Canary, but we have plans to transition to other historian solutions later on. We also get some offline and online data from vibration sensors or vibration readings. We also have health inspection from Maximo. So what we're trying to point out is the entire solution won't work without these data sources. So it's our responsibility now in Workstream Zero to make sure that these data sources are ready. But to caveat, it's not just Workstream Zero's effort. It's actually a collective effort, and that's what I'm going to show in the succeeding slides. Next, please. All right. So before I go into how do we make the data ready, uh, let's focus first on the infrastructure. So where does all of this solution reside? um we put here design and philosophy. So there are certain constraints with our operating conditions here in the Philippines compared to other countries who have better digital infrastructure. So what do I mean by that? Other countries have better telco facilities. They're not concerned about the internet issues that we have in the Philippines. Not all Southeast Asian countries have are archipelagic in terms of geography. we're one of the few countries that are designed like that. So it's really a challenge for digital infrastructure. So how did we come up with the digital infrastructure for Arkanghel? So we have three principles in mind. We have to make sure it's maintainable, reliable, and scalable. So very much similar to your philosophies when designing a power plant, but now we're applying it to your digital infrastructure. So that means we have to be smart about where do we put our servers. We're not TBG, or Thermal is not an IT company. So we don't have the same scale of capabilities and also the same scale of resources to run data centers, like let's say like Google or even local data center providers like PLDT. So we don't have that capability. So the smarter way to do it is, why not just run it on cloud? So it saves us cost in terms of maintenance. And then the capability, we don't have to build everything ourselves. We can outsource to cloud providers. Even the talent, no, we can get third party to help us build the solution in cloud. So that's what we did. Majority of our servers are on AWS. But there's a challenge, or there's an issue when it comes to our sites. Not all have reliable. We have to admit it. No, not all have reliable internet connection. There have been efforts already from IT to upgrade our connections. So our majority of our sites are now have now dedicated fiber lines. So it means that backbone internet connection is already improved. There are ongoing activities to improve Wi-Fi connection within the sites. So even though with these efforts from IT to improve our network, there are still limitations in the local scene. Um, so to address that, we have to put some of the servers on site. So it's what we call now a hybrid infrastructure. So it's not a pure cloud infrastructure. It's not a pure on-site infrastructure, because again, we don't have the capability to run full servers or full data centers. So we've only put a few servers in TSI, and then a few servers in TBI. And then as we roll out to other sites, that will be our strategy. We put some of the one server each site. So what does it do? Uh, it allows us to cache the data that comes from the servers on cloud. So even though that majority of our processing is or servers are on cloud, we can still maintain that experience for the end users. We still can make the system responsive, especially the virtual plant, which is heavy on data and heavy on bandwidth if we put everything on cloud. So we've split the solution, some on cloud, some residing on local, depending on the criticality and depending also on the data requirements or bandwidth requirements. Okay. All right. So that's for the infrastructure. Now, so we've solved the infrastructure part, or at least we already have a strategy on how to make it sustainable. Now, how do we make data processing sustainable? So there's a concept, what we call data pipeline in data management. So data pipeline is just to make it simple, no? It's just a think of it as a recipe. So it's a set of repetitive steps that you can do or that you can scale so that you have templated way of processing your data. So yun lang siya. It's just just think of it as a templated way of doing your or processing your data. So we started that for sensor data for Arkanghel. So for previous implementations of projects that would require data coming from the historian, it's always the project requesting or getting data directly from the historian. Tas kanya-kanyang processing yung bawat system. So what we're doing now as part of Arkanghel is we're standardizing how we get data from the historian. So that way, when we now have other plants that we want to put into the system or in the solution, we just integrate one time with their historian. And then we pull the data, we process the data, we make it ready for consumption for analytical purposes. Now, what's the benefit of this? Long term, not only Arkanghel will benefit from having having our sensor data or whatever analytical data that we need on cloud. It means that it opens up other possibilities or for other solutions to be able to get data when needed. So we don't have to go back always to the plant. Okay, so that's for the data pipeline, which is the second component of the solution. So again, going back, we have a lot of data that we work with. This slide comes from our process team. So what they did was they just tried to map how the data flows into the different solutions. So the operator rounds, digital twin, anomaly detection, and such. These are the same data points that we have earlier in the earlier diagram, the gray layer below. So it's just a different representation. So what we're trying to highlight here is the data doesn't only come from different systems, it also comes from different functional groups. Okay, so that's why I said earlier that preparing the data is a collaborative effort. It's a collective effort, not just in scope of the data team. Okay, next slide, please. So now going into data governance. So since now that if we're really serious about uh, being having a data mindset or changing the way we work with focus on using data, we have to start thinking about data governance because that's the only sustainable way that we can continuously operate on our data. So what is data governance? It just provides a framework. There are a lot of frameworks for data governance, but it just provides guidance. It's still up for us, Thermal, to design our own framework. And that's where all of us would come in. So we have some core capabilities. I wouldn't go into much detail, but what I want to focus on is stewardship. Essentially, we want to come up with policies and guidelines to to make our operationalization and adoption sustainable. So that's what this slide is saying. Okay. Next slide. Yeah. So data governance without stewardship is like a ship without captain, no direction, no trust. So that's how important stewardship is. And as I've been repeatedly saying, every one of us plays a role in data stewardship. So it's not only IT. Yeah. Okay, let's next slide. Next slide. So just recap on the data. So this is what I want to focus on. Um, there are three major roles when it comes to data stewardship. So we have data owner, data steward, and data custodian. Now, it's important that these three roles collaborate, and we have to start realizing that owner and steward are roles coming from functional teams or domain experts. These are the people that are really knowledgeable about the data. So, in the slide earlier, you noticed, for example, CBM data comes from Maximo is actually being maintained by RPM. Now, what would happen if you make the IT data owner of CBM data? We couldn't make sense of it. So that's the philosophy behind data stewardship. You the functional owners or the domain experts, you make them owner of the data because they have the competency to say or to govern how the data is used, when how to say or how to determine if how the data being used is if it's correctly being used, and also they could make strategic decisions on the data. So that's the role of the owner. So they're the overall responsible. Now another role that falls under the domain expertise or functional expertise is the stewardship. So stewardship is just a fancy word for data users. But essentially, what we're trying to do is change the mindset. You're not only using the data, but as you use the data, you're ensuring that you're maintaining the quality of the data. So you're conscious that you're not inputting erroneous data, or if you see an erroneous data, you're cognizant that we have to correct this. Or if you see a certain practice in terms of how the data is being used and that's being used properly, you have to bridge the gap between the owner and the custodian. So custodian, this is IT. So we make sure that you have the system or the solution in place where the data would reside. So these are your source systems or these are your enterprise systems. So it's a bit of change in mindset, what we're trying to do for Workstream Zero, and it will require a lot of help from everyone. Yan. So this is not the end of the conversation. This is just a start. Eventually, we'll start to roll out data governance policies, frameworks, guidelines, but it will be in coordination with the different departments. And so it's not like a ano ba? So it's more of a collaborative way of creating these guidelines and not really a push down. Okay, that's it for Worksheet Zero.
All right. Thank you so much, Mix, for that
Back to Shell.
introduction.
May
All
pandikit
right.
Shell.
Sorry, next slide. All right. So, quiz time. I would like to call on Dinah for the quiz, of course. Okay, so blue team and green team, are we all ready? Uy, char. So, blue team, uy, wala na. Blue team, are we still awake? Green team, isang A for everyone? All right, so quiz time. Question number one.
Let the quiz begin.
Oh, there. That's question number two. What type of IT infrastructure design and environment the project Arkanghel is set up? Oh, get the flag from me. So pag-agawan niyo ako today. Oh, sir. Letter D, hybrid. Oh, correct.
Correct.
Okay, let's check. There. So that's letter D, hybrid. So for real, question number two. That's just a trial for question number one, but 1 point for the blue team. Which of the following physical data or system is used in the So1 Project Arkanghel as data source? Go guys, get the flag from me. Ah, bahala jud mo. Habulin niyo. Ah, okay lang po ito, wag lang yun. Oh, answer, sorry, answer B.
Correct.
Okay, so
Correct.
historian or online data. So guys, dito kayo pumunta, wag lang po doon. Just two questions. One more. Oh, there. Go, Sis Mars. All right, okay. I forgot to remind everyone, please, safety first. Ayan, competitive lang daw. Okay, all right. So let's proceed. Ladies and gentlemen, it's my distinct honor to introduce our next speaker who traveled from the city of Smile to be with us today. Okay. Okay, let's give a big hand for our work stream one, I'm Salazar.
Hello, hello. Yeah, maayong hapon sa tanan. So, yeah, before I start with my technical presentation, let me just take this moment to appreciate the people who have been behind this work stream really. So, as you've heard earlier, already 7 months in the project, but for work stream one, it's actually way beyond 7 months, right? So, we started in September last year. So, the people, I just like to highlight the people that has been involved so far. Ma'am Chang, Sir Anthony, Boss Wewe is here. And also, I just like to highlight also the people that Irene and Carielos really immensely involved in this work stream. So I'll do the honors of presenting this project on the theory level, but it would be better to hear it from our homegrown TSI talent, Khalil, who will be walking us over to the application itself. Okay. So without any further ado, let's turn to the next slide. Yeah. So beknownst to coal plants, especially in PSI and TVI actually, the major risk for our reliability and availability still remains on the aspect of boiler tube leaks. So for context, boiler tube leaks For TVI, it takes 10 outage days. So imagine taking out 10 outage days of running the plant. So really, really a big risk for us. So the gap here is that once the boiler starts up and running, we lose visibility on the thickness of the tubes inside the boiler, thus making it hard to anticipate when's the next leak gonna happen. So that was the question of Matthew earlier. So the solution proposed here is to come up with a boiler digital twin. So what does a digital twin really mean? So by coming up with a boiler digital twin, we're actually creating a virtual replica of our Unit 1 boiler here in TSI. And with data science, machine learning, and AI, we are mimicking what is actually happening inside. So the gist here of why do we have to have a visibility on what's happening inside is for us to be able to come up with a remaining life assessment, or in this case, the remaining useful life of this boiler, which is very powerful tool for us. The second deliverable in this work stream is actually on the simulation tool. So during the discussions with Aiden and QC, what they ask is for us to be able to come up with a simulation tool given the dynamic operations that we're having, right? So we're operating at various load levels and also operating at different coal. So how can we be able to assess the impact of those changes to our operations? So that's the other key thing that we're trying to also solve in this work stream. Next slide, please. So yeah, for the technical approach, so how do we come up with a digital twin? So let me first discuss this flow. So essentially, we're starting off with a operating historical data. So we gather our historical data coming from commissioning period up until the most recent data, which I guess was last year, if you can correct me, Irene. So what we're having here is we do clustering. So in clustering, we group similar data points together based on certain features or characteristics. So in this case, so para siyang magiging similarity index. So in this case, we group data based on load. That's one. And we can also group data based on type of coal. So that's the two main aspects of consideration. Also, but also we're taking into account the different boiler parameters that's actually impacted by the type of coal that we're using. And then what we can come out of this is the operating pattern. So after clustering, we conduct what we call CFD, or the computational fluid dynamics. So what is CFD? So CFD is the use of numerical analysis, data structures, and physico-chemical models such as combustion model, discrete phase model, turbulence model, and heat transfer model, so that in effect we can see the resulting erosion in a specified operating period. So after CFD, validate then these results using our actual data. So coming from our outage data, so we coming from our force outages. So where did the leak actually occur, or what was the resulting tube thickness at the specific portions of the tubes? So we're trying to use that data as a validation point to our findings, which will come up in our CFD. So after we have validated the CFD, so there's actually a criteria there that says pass. So what this pass means? So this is where our awesome team members come in, especially Boss Wewe, ETSV team. So given these findings, is it reasonable for us who are actually operating the plant to go to make sense out of what is the findings of the models of what was really found out in those meetings? So after that, it proceeds with the FEA. So FEA is the finite element analysis. So this is a method used for prediction of how a part or assembly behaves in a given condition. So if you can imagine the boiler, we're actually, for us to visualize the effect, so the effect of erosion in the boiler is actually it's not the same as specific portions, right? So there's gonna be portions that has high erosions, and then there's gonna be also localized erosion. So what we're trying to do here is, if you can picture out the boiler, we're actually slicing it into millions of points, so that we can see that in a local position, what would be the corresponding effect, or what would be the corresponding erosion. And then we proceed with the remaining life assessment. So coming from the findings of the CFD and FEA, what then will be the summation of those erosions throughout the specific portions of the boiler? So what we can come out is, like, what would be the remaining useful life given this X months of operation? And also, consequently, what will be the remaining remaining thickness, right? And then we proceed proceed with the predictive modeling. So predictive modeling is essentially using this tool for us to be able to see what would be the effect like X months from now. And then we proceed with the model testing. So the critical component here is the validation sessions actually. So what do we mean by validation? So the model is going to be producing one model. So the expectation is every time we run a model, we can create or we can get one data coming from the model that's on the thickness. So based on that thickness, we're going to validate that during our planned outages. So what is the actual thickness? So we then have a criteria for us to assess if indeed these models are actually accurate. So that's very important. And for TSI, especially for Unit 1, it's going to happen this planned outage for Unit 1. So basically, we get this outstanding results and we could have this model pass. So yeah, before we launch this. Yep. Okay, next slide, please. So yeah, so this table shows us the summary of data that goes into the boiler digital twin. So as Migs mentioned, this is actually a collective effort in terms of the data sources. So first off, which came out in the one of the quiz is on the historical data. So what we could expect in this boiler digital twin is that data is going to come in the model real time. So that's going to be fed real time to the model. The second one is on the laboratory parameters. I think, correct. Right. So one of the important considerations in running of our boilers is actually the coal parameters. So we take the insights out of this data as to what is actually telling us, especially on coal GCD and at the same time particle size distributions of our sand and the bottom ash. So we feed that also. And then we also have the maintenance data. So when did we conduct tube replacement? When did we have thermal spray? So that's also going to be fed into the data. And the next one is for our validation. So the visual inspections and also the mapping results that we've conducted previously. And sorry. So the simulation data as well as the set point change. So for the last one, set point change, I guess the call here is for us to be able, especially for the operations team, is for us to be very transparent in terms of how we operate the boiler. So the call here is if ever we're making changes or various decisions inside our boiler, like for example, changing the set point for excess O2, we should be able to communicate that in the proper manner as stated in this table. So next slide, please. So yeah, with the next steps, this is already the application, the glimpse of what's expected as an output. So first off, we're going to have the dashboard, and I'll turn over the floor to Bernie which is our technical lead for TVI, to show you guys how the solution is going to look like for the dashboard.
Hi, good afternoon, everyone. So I'm Bernie from uh, technical lead of Work Stream 1 in TBI. So I'll be showing a quick overview of the dashboard of the digital twin application. So next slide. So here in the left side of the diagram, next. So we can see the boiler status. We can see the cluster, the model validity, current model validity, and the weighted average GCV, and also the RUL and the daily D50. In the right side, so we have the graphs showing the time series of each. Next. So for the most frequent cluster, so uh, during the clustering of the project, so we have identified 7 clusters. So 2 high, 3 medium, and 2 low. So in this application, we also added here the NA. So in case of there will be unknown in the application, so it will be shown here in the application. Then the next for the current model validity, so this is calculated based on what was fed to the application. So in the uh, during the loading of uh, operating parameters we have identified previously, right? The 7 clusters. So we can change here. So depending on what was unknown or rather different from what was programmed, so or diff in case there would be different goal types, so the model validity would go down. So in case there would be it will reach the threshold of 80%. So by then we can consult repco. So and they will confirm um if it is just an outlier or we need to retrain the model. Next slide. So for the call types, the third one from the application. So this one is just a weighted average of the GCB. It will be shown. So depending on what type of call it is. Then next slide. Then for the RUL, the worst case, and there's two here, the worst case and the most likely. So for the worst case, it is calculated based on the erosion rate on the highly eroded zone. So in the that red colored line, so the, this is usually the worst. So the least amount of days or months that the application is able to detect the next boiler tube leak, and the yellow one is the most likely. The next slide. Here in the D50, so this one is the value of the D50 daily basis as updated in the laboratory. So this is updated daily. Um, so for everyone's information also, and in this graph, you can change it by either weekly or monthly, depending on the user preference. Next slide. So here in the criteria showing the green and yellow, orange, or red color. So this was actually defined during the user requirement in the FDS. So for green, we have if the boiler tube leak has 2 years of life remaining. So this would be the normal. Then the yellow, 1.5 year to 2 years, and the orange, 1 year to 1.5 years, and the red, less than a year. So that's the remaining life settings in the uh, as agreed in the FDS. Next. Then here in the when a warning message pops up in the application, so you can click the view and you will be directed to the different page depending on which area the tube leak is going to happen. So there will be the warning status. So you will be able to see the tube number, elevation, the zone on which the area that it will probably fail. So and the type of tube it will detect, and the height and the area as well. So next. So that would be all for the quick overview of the dashboard. So Eins, I will be turning over again to Eins. Thank you.
Yeah. Going back to the functionalities of the dashboard, right? I think the key consideration here is this model is based on historical data. So one important parameter that was shown earlier is on model validity. So what does model validity actually mean? So it actually describes how our current operating conditions align with our historical data. So we measure that in terms of that index. So the threshold again being is 80%. So what we can come out of that is if it drops below 80%, what does that tell us? So it actually tells us that this operating regime that we're having right now is actually not accurate or not the same as what we've currently operated on. So what this calls for like reclustering or maybe this could in fact be a new coal that we're feeding. So that's on echoing the important aspects of that what Bernie presented. So let me proceed on the simulators. The simulator tool is also a helpful tool for us. Considering that we're having different load changes, and given the data from Kobo, or the commercial operations business unit, so they're giving us the yearly look ahead of the loads, right? So we use that data and then combined with the shipment forecast of the FMT as to how our tubes would look like given XX amount of months. So so yeah, that's the context of this one. So next slide, please. So yeah, so the some data inputs considered in the simulator is of course um the specific time periods a specific coal type will be fed. So the question is, what about if the coal is like a trial coal? So what is the consideration here? So again, the main component here in consideration of this tool is that it has to be data driven, or meaning it has to come from actual data. So we actually have to require 10 days of operating data, and then we allocate that or inject that into a tool for us to be able to come up with a data for that specific coal type. So here, what shown here are different specific time periods for different coal types. And then what would actually come out of this one is the remaining useful life, as shown earlier, the worst case and the best case. Yeah. And also, the important parameter considered here are the bed material particle size distribution. That would be best fit for our operations. Next slide. So yeah, we then get the simulation end results, and we can use this data, most especially in timing for outages, like how is it going to be timed and how is it going to be strategized, which will then be communicated to our FMP and SEM and other departments. So what we can actually get from here is, for example, um we started for some time, and then given this we select the end date and how it would look like given the end date that we've selected. So for example, this one is February 25. So how is it going to look like? And then as compared to January 14, 2027. So what we're actually seeing here is the heat map. So the color signifies a specific thickness, a degree of thickness, with red and the violet being the least favorable ones. Yeah. So yeah, for maintenance data, I'll turn over the floor to Khalil.
So thank you, Eins. So I'm Khalil Destin Katakutan from Workstream 1. So for the maintenance data from the navigational board, next slide, please. The maintenance data shows you the tube replacement, the thermal spray, and pad welding. Here, once you select the maintenance activity, you can, there are two options that are presented. So it would be the recording or the visualization of data. So for the recording part of the maintenance data, you can see here in the image 3A that the maintenance data, you can input your maintenance activity directly into the application. So in this part, there are two modes of input. So one was the I mentioned earlier where you can manually input in the application, and the other is that you can use the template from the application. So from the application, you can download the template and input your data offline, and then later on, once the template is complete, you can upload it into the application. So for the other recorded items in the application, you can see here in the lower part of the slide for the maintenance data of tube replacement. For the other activities of the maintenance data, next slide, please. So you can see here that the other recorded items are stated in the lower part of the slide. So for thermal spray coating and pad welding. So next slide, please. Moving on to the next part of the navigational the navigational board is the inspection data. So similarly with the maintenance data, you can see the manual ultrasonic testing inspection and the robotic inspection. So for in this page, you can also manually input the data from your manual UT, supposing you have a few points only. But in case you have a lot of data, you may also use the template similarly with the manual inspection. up. So next slide, please. So for uh, this is an example of what the manual UT and robotic inspection mapping would look like. So in the left side of the slide, you can see the image of an example of UT data input. And from the right side, you can see the robotic inspection. So the thicknesses of the tubes will be color coded based on the gradient as shown in below. And there is also an option where you can there's also an option where you can visualize the data along with the maintenance data, as you can see here in the lower right corner of the slide. So next slide, please. So for the next feature of the navigational toolbar, it will be the reports. In the reports, you can the reports from the weekly and the monthly data will be presented. You can view and visualize the reports here in this section. And for the digital twin, it would send reports weekly every Wednesday that contains the predicted tube thicknesses and the remaining life assessment. As for the monthly reports, they would send it uh, by the end of the month, and the reports would contain a summary and a compilation and a comparison of the weekly's tube thicknesses along with its current RLA. So I think that's for Workstream 1, Boiler Digital Twin. Thank you.
All right, quiz time. Green and team and blue team again, safety first. Okay, round two. Are you guys ready? Letters A, B, C, D. Isang A when you're ready, guys. All right, so question number 3. Again, get the flag from me. Key function of boiler digital twin is to estimate the blank of the actual boiler based on the erosion rates of the boiler. A tie. What's the answer, ma'am?
Letter A. Remaining useful life.
What's your name?
Listen.
Okay, so 1 point, another point for the blue team. Green, green. Sige, tunga na po daw. Alright, next. Question number 4. How many clusters were built in measuring the model prediction validity? Oh,
7 clusters.
what are the clusters?
7.
Cluster 1, cluster 2. All right, so 1 point for the blue team. I guess we are at 2 all. So isang A for the green team and the blue team. All right.
All right. So, up next for the next work stream, let me introduce our next speaker who will be discussing a topic that is crucial in today's data-driven world. Of course, none other than, I think, no introduction further. You already know our next speaker. Let's give a big hand to Irene Romblon Salvador.
Hello. So good afternoon, everyone. I hope we're still wide awake, coming from a very technical discussion from Digital Twin. For Workstream 2, it's anomaly detection. So predictive analytics by anomaly detection. So in this work stream, we will leverage algorithms, advanced algorithm, and advanced machine learning. So for us to recognize and be able to anticipate potential issue or troubles in the future, forecasting the issue as well, for us to improve our operational efficiency,
lessen our maintenance and operational costs related to the damage or force outages. So this concept is not new for TSI. Actually, TSI is mature in using predictive analytics by anomaly detection. We already have GE Predicts APM for TSI. So our team, ONM, RPM, our subject matter experts are who have domain knowledge already utilize this one, and we already have good captures from GEAPM. But later on I will give further context why do we need to move and what is the benefit of us TSI moving from GEAPM to Aviva predictive analytics. But first, let me share our deliverables for this work stream. Together with work stream 0, we will have we should be able to easily integrate our historian data coming from cannery, and what makes is further explained earlier, we can transition to Pi later on and easily integrate that data, real-time data, to establish a database wherein we look into recognized normal behaviors coming from uh, number or multiple user parameters coming from our historian, and also to detect subtle deviate. So take note of the word subtle. Subtle. So, in a relation, for example, for our tube leak, what is subtle in a tube leak? So, if there's a little pinhole, and if it's deviate from our normal behavior, anomaly detection can detect it and can forecast it. What will be the time, and maybe detect it, actually not maybe detect it when there is still little or minimal damage to our boiler, rather than, but disclaimer, it cannot detect sudden. So subtle and sudden. So yeah, but I know spell. But I know we are mature and using this predictive analytics, and I know you're asking what is it for us? Why do we need to move? So later on, but next slide. So I'll have to discuss what is the manual monitoring. So given that example, if our RPM guys and our operation guys are monitoring a system, correlating different parameters and monitoring periodic a lot of parameters, so it will not make a sense of it. And it's very historical driven, domain knowledge driven. What we have now, later on, in the new ways of working, having predictive analytics by anomaly detection is that we'll become have a proactive approach to this type of events. So we'll have forecasting and a subtle change of behavior. We can detect and alert, and so that we can cohesively talk about and have a platform and ample amount of time to decide and to plan for the next action. And it's more of really giving our end user the tool to be smart driven in their decision and to really have a proactive approach when it comes to this type of anomaly. So next. So why move? So maybe Jason is asking this one because he is from RPM. So but uh may I also like to take this opportunity, like Ans was for digital twin, is to really thank our ONM and our RPM team as and also our ETSV guy, our domain expert, because what also is our learnings from GEAPM is that for this work stream, we heavily involve them in the development of our models. Why? Because the important in AI is operationalizing it. Tama? Operationalizing it or giving sense to what is the data. So without the domain knowledge touch base at the very beginning, we will have a difficulty in correlating and giving a sense of what will be the alerts be, what will be the diagnostic of that alert, and what will be the next step or the prescriptive. So I want to give this opportunity and give thanks to the team in O&M, RPM, Dindo, Jason, our domain experts who actively participate and really contribute for the betterment and for the improvement of our predictive analytics. Yeah. So what are the difference from GE moving to Aviva? Number one, in GE, we cannot create additional model. If we will create, we will send the ticket directly to GE. Example, Dindo wants to add boiler acoustic. He needs to send out a request. GE APM guys need to do the model creation. Or if Dindo wants to add another monitoring parameter that is not really part of the template, we will need still to ask for GE. But now with Aviva Prism, we have the liberty to customize our template, which we already did during our internal review and creation of our template. So our template now, if it's not a directly uh, representation of an old GE model, but it's if not, it's an improved uh, with the improvement and revised tweak to really see or a representation of what we need on site. Next. Another one is in model training. So it's very easier now for key user or super user who will do the model training because in Aviva Prism, we can correlate multiple parameters or give a sense what is the relation of this parameter to each other. Next. And another key features is that during training, model training, we can use back testing of historical failures. Or if the model that is being trained when we use our historical data, example, past boiler. Hello? 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 Past boiler tube leaks, our level of confidence to our model training will be higher because we can do back testing or we can check if really the model can predict the boiler tube leak before. At first, we will blind them and we will train them. We will train just remain the normal behavior, and then we will try to use it if the model really sees our historical damages or historical failures. So our level of confidence of our model training will be higher. We don't have that in GE. Also, one key feature is forecasting. So it will also be a tool for the end user, for example. Yeah, we have alert now. So what now? What are the worst case scenario we're gonna look at if we're gonna not change any operating parameters or do anything from it? So we can predict or forecast when is the worst case scenario and will it hit us hard. So it can be a tool that our subject matter expert, our facility head, our O&M head, and our RPM can utilize and leverage in decision making, which we don't have in GE right now. So are you excited to have a look on how we will have case management from GE going to Aviva? Sure? I want to hear Ganesh say yes. Okay, for our project demo, may I call our technical lead for TSI, Elvan. Let's give him a round of applause. So, so baka gusto niyo pa ng quiz. May prize pa ba? Medyo matapang si Lyra, hindi pa regular. Tinawag ko si supervisor, Lyra.
All right. So while waiting, would like to remind everyone to please don't forget to scan our QR code for your attendance. And also, if you have any questions or clarifications, we have allocated the time slot at the end of the session, so you can directly ask our speakers about your questions. And also, we have a Slido. That is the second QR code that is posted in this room. Okay? So if you have any questions para di nyo makalimutan, you can put in your Slido link. All right? And of course, don't forget your attendance. Thank you. Ano?
Snacks muna, pwedeng drop na.
UHM?
Ah,
UHM.
o sige, pwede naman.
Okay. Sige, UHM. Okay, so while we're setting up for anomaly detection, I think we can proceed to the next work stream. Okay, so our next speaker will share insights on the principle and benefits of unified health and how this approach is shaping the future of our planet. So let's all welcome our next speaker together with his technical lead, Mr. Jojo Calpito and Jeremiah Miranda.
Okay. That's so please don't mind the ID picture. So hindi pa tayo nakapagpa-picture. Okay, so let me introduce Unified Health Management System. No? Next slide, please. Okay, so basically, Unified Health Management. So from the from the title of the work stream itself, um, so we have all these data sources, no? So coming from different work streams, different data sources such as Canary, offline and online CBM data, operator rounds, Maximo, and so on. So just would like to have a rhetorical question, no? So once we have all these data, so what exactly do we do with it? So what happens? Well, coming from my experience on my previous company, so each of their a department owns a particular process, a particular measurement, depending on the equipment that they cater on. So what Unified Health Management does is basically marry all those data. So as to have a holistic view on the different data sources. So there might be interdependencies on, say, the water treatment, um, on its effect on the boiler health, on the tube health. So those possible scenarios, no? Okay, next slide. Okay, so basically that's what UHM does. So how do we do it? So coming from the infrastructure of workstream zero, so we collect the dynamic data, the operator rounds, and the static data, and then we route those data coming towards the different work streams. So we have digital twin, we have anomaly detection, and then
what happens then is UHM aggregates those data for it to be visible to everybody basically. And from that, that comes with that in turn turns into a powerful tool. So why? So as an operator, probably you might not have that visibility on the CDM data. So you might not have the visibility of the ChemLab data. So with the tool UHM, so that becomes visible to everybody else. So just a disclaimer. So the system takes maturity, of course. Primarily, we have identified the primary functions of the identified subsystems at this phase. So as the system grows larger, so it needs a lot of inputs coming from everybody. So there will come a time that there will be questions like, why is this not on the UHM platform? Why is it not being monitored? So those kinds of questions might prompt to everybody giving the chance to contribute to the system. So primarily for phase one, what we did was to set the backbone. So once we have deployed this, so everyone of course I implore your help no to make the system usable, because that depends of course on the users themselves. Okay. Next slide, please. Okay, so anyway, we're talking about setting the backbone. So how did we do it? So Repco introduced the template of policy design template, which is using the RCM concept. So basically, we take up assets, subsystems, and identify the primary functions, secondary functions, and then develop based on those functions, what sensors or what indicators do you use to identify failures. So if you look at it on a asset hierarchy perspective, so you start at the top, so from the boiler main systems, and then you granularize those systems into subsystems, and then eventually landing on the lowest level, which are the indicators. So um, UHM provides that possibly a chance for those sensors to be kumbaga mapa sila. So in a way that you group those subsystems into those indicators into functions, and then that way you can estimate the functional health of those subsystems. Oh, anyway, so this is just a snip coming from the PDT development, no? Which I'd like to thank the ONM, RPM, and other departments no, who have contributed to this. And without them, they're very instrumental to have these PDTs accomplished on time. So yeah, no, give ourselves a round of applause po, no? Okay. Anyway, this is just a snip. So as we can see here, we started from the boiler, and then we have uh, identified the specific subsystem. No? So in this case, feed water system, and then we have here the number of functions and policies that we have included in the PDT. Next slide, please. Okay. So based on those functions, we have identified the specific indicators that we will use in determining the failure of that specific function. So in this case, as a sample, this is coming from the CBM data of RPM now. Okay, so we have here we have set the limits, we have set the oh sorry, this is historian pala. Okay, so anyway, we have indicated here the tag description, the tag names, the operational limits, and the frequency of gathering the data. Next slide. Okay, for the last portion of our PDT here, um on the left hand side of the screen calculation. So in this case, it's just very basic. It's a min max probably a simple calculation. So it depends, no? We have the liberty to create our own monitor monitoring, no? So what we did with the team, no? What we did was when there's an available curve, so for example, the relationship of x and y values. So we turn that into expressions. We turn that into formulas. It depends on the relationship, whether linear regression and so on. So we have the liberty to do that. And then for the criteria, we have here it's either we just replicate the ones that are set in the DCS and so on, or depending on the result of the expression, depending on how you want it to be calculated. And then most especially one of the more important parts of the PDT is the failure mode description. So once an alarm triggers in the UHM platform, um, this will prompt. So for now, it's just free text. So we have to indicate here what could be the possible failure modes, what could go wrong, what are the causes, what could be the effects, and then um um on the last part of the PDT, you can see here the prescription. So what we aim to do here is to link UHM to Maximo. So we have what they call that shit, job orders or job plans, yeah, job plans. So that's one of our plans to link the specific failure mode and what job plan to do should an alarm arise. So that's the last part of the PDT. And then once we have configured or developed the PDTs, we will be loading it to the UHM platform. That's it. Okay. Anyway. So you can see here, this is the UHM platform, no? So from here you can see the breakdown of the assets, no? Plant breakdown structure from the turbine and then broken down into subsystems. So as well as here, if you see in the boiler, we have broken down into subsystems as well based on functionality. And then we have here the indicators. So for the indicators, so it's not limited to the ones loaded in Canary. It's not limited to the ones in the historian. So uh, we will integrate all the indicators coming from the work streams. So we have remaining useful life coming from work stream one, prism signals coming from work stream two, and then we do have the parameters coming from operator round. So all of those will be aggregated to the UHM platform. Okay. Ay, one slide back. Ay, back. Sorry. So we do have 8 data sources for UHM. And then what UHM does is yun nga, aggregate, diba? So and then it will have a single outbound signal towards the virtual plant, which will display then the health status of the equipment, whether it's green, amber, or red. So depending on the results of the policies. So that's it for UHM. So ayun, quiz muna tayo, no? Okay. Thank you.
Okay. So there's a change in the instruction from our hosts that no more running, no more getting of the flag kay basig akong mabunog. So here's what you're gonna do, green or blue team. The first one who can stand and then shout the color of your team. For example, red B, like that. Clear? Okay. Green ta sir, green tapos blue sa pikas ha. Okay, ready? Green gets color blue. Question number 7. This document or template employing reliability-centered maintenance approach. So somebody answered here B, which is the policy design template or the PDT. And someone there is the performance design tools PDT. So both are correct for the acronym, but the meaning of the PDT acronym is the policy design template. So 1 point for the green team. A. Okay, question number 8. There are 8 data connections inbound to UHM system and 1 data connection outbound from UHM. Name what is one data connection. Okay, so outbound. Uh, so time's up. The correct answer should be virtual plant because it's outbound. So A is wrong. A is wrong. Score is green for 3 points for the green team and 2 points for the blue team. So 1 point Rai Ligas. All right, go Sis Mars.
All right, so for the next speaker, would like to call on, of course, our technical lead for asset information management systems and verbal plan. Let's give a big hand to Cherry Gakal.
Maayong hapon sa tanan. So let me introduce myself. My name is Cherry Gakal, the technical lead for Workstream 4, specifically Asset Information Management System. So together with me, under Workstream 4 is Sir Jojo Calpito as the project manager and Sir Genesis Doldef as the project director. So for the project brief, so relating to asset information management system and virtual plant. So this is asset information management system and virtual plant are actually interconnected systems. So let me explain first what is AIMS. So AIMS is like a centralized repository of informations pertaining to a specific asset. Whereas virtual plant, this is the 3D representation of what is our physical plant right now. For example, here in TSI. So what we're gonna be covering for AIMS and virtual plant for the phase one would be for TSI. It will be the Unit 1 um, boiler systems, and for Unit 2, it will be uh, for the TVI, it will be Unit 2 STG systems. Okay. So, what are like the what's in store for work stream 4? So first, this is work stream aims is a comprehensive digital visualization. So in here, in terms of the virtual plant, there's representation of like the asset health summaries and details, the insights. Um, Together, this is seamlessly integrated with what is the specific asset data. And another thing is that we have centralized information access. So with this, our existing platforms right now, in Aboitiz Power is Box, Maximo, and IRS. So this existing platforms or data sources will be integrated to the AIMS portal itself. So treat AIMS portal such as a like search engine optimization where you can search a specific tag or asset code, and after that it will give you results linking to specific documents, engineering drawings, and the likes of a specific asset. And with this, we have enhanced decision making. So, few timely data driven insights provided by Unified Health Management and Systems Virtual Plant, focusing on asset health and visualization. So, next slide, please. Okay, so for the solutions overview, so um, we are like linking the specific assets. For example, here in the plant, for every equipment or components or pipelines, we have a asset codes or asset tags for that. So those asset codes and tags are interconnected with other documents as well. So that is the main role or main goal of AIMS, to like interlink all the documents that we have to this specific tag. So currently for phase one, the documents that we're gonna be covering is the policy, procedure and forms, the engineering drawings, inspection and test plans, and OEM manuals. So with this, we are creating like a cross-reference supporting daily operations, maintenance, and project planning and execution. So it's pretty much like this. The tag or the asset code itself in the center, and then it will be interlinked to maintenance, historical maintenance data, 2D drawings, reports, QA documents, incidents report, data sheets, isometrics drawings, and 3D models. So that's it for work stream 4. I'm gonna be turning over to Sir Jojo for the project demo.
Good afternoon, everyone. All right. Okay, so for the project demo, I know all of you are very busy, no, but thank you for taking time to attend this technical roadshow. And the team did prepare a user story on how is this applicable in your specific area of responsibility. So what I wanted you to do is try to reflect with what we'll be sharing. How does this impact my role? And what are the different features and functionalities of the tool that will be relevant as you perform your specific functions. And we would like to get your inputs as well. And also, we want this workshop or roadshow to be experiential. So today we'll be sharing with you the initial output of from the 5 6 months as we progress with the project. And we want to thank you for being part of this journey. No? And we want you to experience it actual today here in TSI. So next slide, please. Okay. So for today, we did prepare a story around the boiler tube health status. Uh, as mentioned by Eins earlier, so this is one of the most critical concern that impacts our operations and not only our operations, even our revenue, the way we do things. And with Arkanghel coming in, so we did prepare this flow for you to appreciate how will this processes come into play as we do it as part of our new ways of working. So it usually starts with monitor. So we will be monitoring our asset health coming from the different data sources earlier. So we have unified health management. We have data coming from the anomaly detection. We have data coming from rounds and from digital twin. So all of this information, we monitor it via our virtual plant. So what we have here is our actual virtual plant model for PSI. So we'll have an actual simulation later. So after doing the monitoring, we do navigate. So our operators will navigate to the unified health management, which aggregates all the data coming from the different data sources, as mentioned by my 8 different data sources. And you can do investigation and identify where the problem really is coming from. So after navigating, you identify the cause of the warning or the alarm, and then you have the data now. What are you going to do with it? So next step is you analyze. When you analyze, the UHM system will direct you to the third-party analysis, either in digital twin, in anomaly detection. It is also capable in providing you with diagnostics and even next steps on what do you need to do for you to be able to rectify a particular alarm or warning that you're getting from the system. And then after analyzing, so we've already analyzed what's causing the alarm. We need to plan now. What are we gonna do with it? So we plan for the maintenance actions. So that's where the job plan comes in, and all our planning team activated and doing our outage planning, our preventive maintenance, and all the different task force or teams that will be working for us to be able to address the warning or the alarm or the problem that we're having. Okay, so to discuss the story around the boiler tube health status, so may I call in Eins?
So as discussed by Jeremiah earlier, Unified Health Management overall health of the so overall, but it also looks at into specifics. Like for example, in this case, what we're trying to showcase to you right now would be on the boiler tube health status. So what we're actually showcasing also right now is the integration of the three work stream. First is on the digital twin, next is on AIMS and UHM. So what is the boiler tube health status? So for context, let me run through it again. So for boiler tube health status, we're looking at the boiler tube conditions wherein we can determine the remaining life assessment, also the erosion patterns and the erosion locations. So as displayed also in this pictures right here. So Sir Jojo will look into the plant system as to what is alarming.
Next slide, please. Okay, so the user story that we'll be walking you through today is coming from the AIMS virtual plant. From this model, we'll do the routine operations monitoring, and then we'll monitor the asset health. And then if we found a system, a warning from the system, I'll be walking you through and navigate to the unified health management to identify what's causing the warning or alarm. And then from there, this system is also integrated with the digital twin system that we will be rolling out for for us to be able to conduct more analysis. And also, this integration will also cover the access or the interface asset information like PNIDs, engineering drawings, and later on, even information from Maximo, IRS, Box. So we'll be able to access everything in virtual plant. Okay. So without further ado, so I am here to present to you. All right. All right. Okay. So what we have here right now is the 3D model of TSI. So part of the journey of the project is we provided our vendor RepConnex with the Navisworks. No, so basically the 3D model when the site was commissioned. So and they did digitize that using Aviva E3D. Okay. So here, if we want to check um, the overall equipment health status of our power plant, will be able to access it via the visual query. So in the visual query, we'll have there the overall equipment status, wherein if we see here, there are three alarm. It's either we're having an alarm, which is in red, and then how many assets are in normal condition, which is in green, and then how many assets are in warning, or which is in yellow. So for example, I click on warning. So here it says that the warning is coming from the furnace. So if I click further, it will automatically zoom in the 3D model going to the specific asset or equipment causing the warning. So here, we'll be able to see overall in our power plant where specifically the warning is coming from. So if we want to investigate, this system is integrated with Unified Health Management System. So if we click here extensions, and then it will show the health status or the system health status of our power plant. And then if we click here, we'll be able to see which ones are causing the alarm or warning. So earlier it says that the warning is coming from the boiler. So here, if it details that the warning is coming from TSI Unit 1 boiler, water or steam system. So if I click on this particular warning, it has a link to UHM. So when I click on this particular link, it will redirect me to the UHM system. Wherein, as discussed by Mai earlier, we did create policy design templates that structures the hierarchy of our assets, coming from the plant level down to the system level to the subsystem level. And then there, the actually we did identify which among these assets are the single point of failures, where the chronic failures are coming from, so that we'll be able to interface it with our virtual plant and with the asset health monitoring. So here in this specific policy, we can see that the problem or the warning is coming from the furnace front wall tubes of the boiler. So if I'll click here, it will detail the diagnostics. So the system is be able to provide us the diagnostics that according to the digital twin, which applies simulations and data-driven approach, uh, to map the relation between operating conditions and erosion rate. So the result is it will provide us the remaining life prediction. So later, Heinz will be walking us through the capability and how it interfaces with the unified health management. Okay, so there's a link specifically to this warning, and then if I click link, it will redirect us to the digital twin, which has an integration with the unified health. Okay, so to discuss further analysis on where the problem is coming from, go ahead, Heinz.
So this is actually a glimpse of what Khalil and Bernie was talking about earlier. So once we click the area in the UHM, that will direct us to the boiler digital twin, showing the specific alarm that we're experiencing. So by the way, this is still a demo mock-up. So please don't believe the data that's being displayed here. It's not that, it's alarming to see this one. So so here in this area here, you're going to see the warning status, which is aligned with what we had in UHM earlier. And here, the area is this section is the specifications as to where the alarms are popping up. For here, this is again a demo. It's at tube number 1 to 8, elevation 0 to 8,900. So what we can expect here is there's going to be a specific tube locations. If in case there's many, then a lot will also pop up. So for right now, this treat this as the like mock-up data for now. And also, what would be relevant to our planners is, for example, is to determine which specific location the leak's going to happen, the zone, the type of tubes, height, and the area. So really important for our planners. Also displayed here are basically the heat map or the degree of deterioration inside the boiler. So the contours or the colorations is based on a specific criteria that the users have set. So right now it's not yet final. We've had initial discussions with the user last week, and we're still trying to improve it. But again, this is just a glimpse of what's going to be deployed. So here, this is the mock-up of the boiler showing the specific colorations at specific sections of the tubes. So here, the specific functions here is once we click here, so we can actually see what tube number, what elevation, and what the value is in terms of the remaining life. So this is sample again a sample. So what we can get from this is that the planners will definitely use this in terms of planning their strategy as to how the scaffolding is going to be erected, which Sir Jojo will also be showing later, and also what type of maintenance activity is going to be conducted. Like for example, in this area, considering that it's green, is it right to have thermal spray here, or like do we have to conduct tube replacement here? So really useful informations here. And in the case of our boiler experts and boiler specialists, um, we can also extract this data quantitatively using CSV files or Excel files for us to get a numerical values of the thickness, remaining tube thickness at specific time period. So yeah. So once we've already discovered what the alarm is about, we'll go back to UHM. Back to you, sir.
All right, thank you, Heinz. Okay, so after conducting a detailed investigation using the boiler digital twin, now we have uh, insights on where the problem is coming from. And that is an input to our planning team on what are the particular activities that needs to be done. And then for us to be able to do that, if I may go back to UHM, if you can click mix UHM, nawala eh. There you go. All right, thank you. All right, thank you. Okay, so in UHM, aside from having a diagnostic, it will also provide us with the next steps. So it will detail what needs to be done after conducting the detailed investigation. So here, we've detected that the boiler tube, that there's a boiler tube leak. So we can now trigger the maintenance boiler senior specialist. So he will verify the alert and check the model validity if it's more than 80%, including the leak location, also the elevation, the tube number, etc. through the system. So if the model validity is acceptable, this is will be consulted as well with ETSV boiler expert for actual boiler condition. And after consultation and investigation, so the maintenance manager, so with the approval of the facility head, will assess if the maintenance activity like tube repairs or replacement is needed or can be done during normal operation, or if outage is needed. So the model can also provide the remaining useful life of and number of months or as basis if this is before the planned outage of it or if forced outage is necessary. So here the system will be able to uh, provide us the next steps, and at the same time later on if we'll be having a mapping on what needs to be done, it will also map to who will do what. Go ahead, Ron.
Can we put in the next planned and then the system can tell us well in advance whether they think the tube will make it?
Actually, for the planned outage, so we already have that plotted, right? So we already know that as part of our maintenance strategy. But what we're predicting as part of the boiler digital twin is the remaining useful life. So it's more on a proactive approach
No, no,
rather than
I
yeah. Go ahead.
understand that. So let's say it says it's got 2 months life.
Mm.
Okay, had more, right? So why don't we put the dates of the outage in and it'll say, yeah, these tubes will make the next outage or not.
Yeah.
Instead of just predicting saying say, it'll make it to 2 months after the next outage or a month before.
Yeah, so we want to strategize if this unit, example, unit one, will reach the next planned outage. Yeah, we can.
All right.
And actually, that's one of our, we'll get that to you as soon as possible.
Yeah. Ron, I think to your question, you actually have the days here, remaining days in terms of the life of the boiler, so you can plot to the next outage if it will make it.
Yeah, but if it alerts us beforehand, let's say we're done with the outage, right? We're just finishing an outage. We have the next date already in. With that data from the outage, it should be able to say, yeah, everything you've done is going to make it to the next outage. And that's useful information versus having to go look, well, this tube's 2 months, this tube's 6 months. You know what I mean?
Yeah, correct. We should be
And
able to rebaseline with the
yeah,
digital twin model.
Yeah, as long as we have already the maintenance report and maintenance data, this outage,
yeah,
and put it there. And also we can monitor if, example, we have very low coal and if it really affects our remaining life. So that's the one we'll have to monitor.
yeah. But you said it takes 10 days, right? When we change coals, 10 days worth of data for it to produce the results.
If that is a new, if it will create a new cluster.
If it's a new coal, yeah.
Yeah.
So then we could look at a outage, say, yeah, everything's going to make it, and then we change coal 6 months in, run for 10, 15 days, and all of a sudden we get all these little alerts. If you keep doing this, you're not going to make it. Would it tell us that? Do you understand the question? Did I make sense?
It will lower the accuracy of the model. So for it to be a factor, we'll have to take into the data, the requested 10 days data to really factor in. It will say
Yeah,
that
yeah. After the 10-day run or whatever it is, then it should be able to say, yes, with this new coal, you're going to last for 6 months, 8 months, 10 months, two
yeah.
months, 1 month. Will it be able to do that? So we can say, yes, it's going to make it to the next outage. So you guys shouldn't have to worry about it too much.
Mm.
Or it's not going to make it to the next outage. So we need to decide something about the coal that we just
Yes.
bought.
Decide on the code or decide on the operating parameter, but better
Yeah, yeah,
decide on the
yeah,
code.
yeah. Okay, all right, cool.
Yeah.
All right. Thank you, Ron. Okay, so going back in UHM, so now we know the diagnostics, we know what are the next steps. So based on what was shared earlier by Jeremiah, so what we configured using the policy design templates, we configure it using the UHM system, wherein we set we set the operational parameters, what's the logical condition, the criteria setting, the persistence, and we'll be able to check if we were still within the control limits based on the data that we did set. So if we are above or below, that's the time that it will trigger a warning or alarm. So here, so we'll be able to also associate this with the later on with on how it was calculated using the parameters, and even associate the equipment with the asset code when we interface it with Maximo. Okay, so now we already know what we're going to do based on the insights that we get from our system. So going back to the 3D model. Okay, so here one of the capability of the virtual plant is, as discussed by Cherry in Ames portal, will be onboarding or associating the documents, the Maximo information, IRS information related to the equipment. So here, if we'll click on the documents related to the boiler, we'll be able to identify what are the different engineering or technical documents are available there. So for example, we want to navigate on a particular PNID related to the boiler. So if I click on this one, it will open up a PNID related to the boiler. So it specify on which particular tag the warning is coming from. So in this specific sample, we've been able to digitize our PNID into an intelligent PNID, which can be an input to our planners. All right. So when I say intelligent PNID or smart PNID, so what we did is we associated the tags with the specific equipment that we have in the plan. So here we have a side by side PNI and the 3D model where the problem is coming from. We can also take a snap here. So taking a snapshot so that later on, if you want to see the collection of your snapshots, you can access it here using the collection view. And then if you want to go back to it, just click to it again. And then you can also send it via OneNote, or later on we will configure it to Google so that we can use Gmail and then uh, send it to your email. Parts. Ngayon, maglalagay. Log out. Sige. Resume. Okay. So we'll just log in.
Okay, so while waiting, I just wanted to remind everyone again, if you have any questions that you wanted to discuss later, we have Slido. Please scan the QR code. So while waiting for the server, would like to ask actually the feedback of our audience. How was the training or the how was the roadshow so far, Miss Chang?
informative, and with all the knowledge and information that we presented. We're so excited.
Okay, Miss Chang, so excited. How about Sir Greg? What can you say, or do you have any points that you wanted to discuss later at the end of the session? We're almost down to the work stream for this session.
Yeah, I think this one, the advance is if this system will be connected to the warehouse where all our spare parts will be cataloged, and you can see on the PNID that when you see the drawing or in the PNID, the part number or the spare parts, it is very easy to make the work order or the work package, the inventory of all the spare parts for the equipment.
So for further improvements, sir, like connection of PNID with the spare parts number for inventory purpose. All right.
Yeah.
Okay, going back, Sir Zo.
Okay. Apologies, team. Okay. So going back, so earlier we've been able to navigate on the PNID related to the boiler. And we've been able to identify specifically on what particular tag it is associated to. So, so part of the capability of the tool is we've been able to model it side by side with the PNID against the tag and taking a snap and having a collection and sending it via Gmail so that it's an input to our planners. And also, if we want to navigate, I think I did stop wherein I was about to discuss about the smart PNID capability. When you click on a particular tag, for example, it will be able to zoom in on where that particular equipment is in the uh, in the i- in the virtual model. And then you can again take a snap of this one. And then if you want to open, for example, a particular document related to that particular tag, so it will, okay, it will show you where it is specifically in the engineering drawing. So another capability of the tool is, so after knowing where the problem is coming from, we can also do a measurement. So for example, for this one, so we know that the problem is coming from this particular area, and we can use the measurement capability. And if we want, for example, to erect a scaffolding, so we'll be able to measure it that if it's from this portion, it's like 29 meters from the floor going to that area, so that high of scaffolding. And then, for example, if we'll be deploying a crane, so it's 41 meters going to that particular area. So we can again take a snap of this one so that later on we can send it and it can be a compilation of inputs as do the planning. Also, another capability of the tool is walking inside the power plant or walking inside that particular building. So here we can do a sectioning uh, wherein we'll be able to navigate on the particular equipment. And then we can click on the walk capability. And then if I'll put this here, it will automatically bring us inside of the area. So it's like having a virtual walkthrough of the power plant. Yeah, there. So this is based on the actual 3D model that we did provide our partners. So basically, you can do a virtual walk inside the power plant. You can roam around virtually and even measure it again. So for example, you'll be conducting an activity in this particular area. So if you want to measure it, so you can easily measure it. So you need like 2 meters of scaffolding that you need to erect in that area. There you go. And then aside from the sectioning capability, you can again take a snap and then it will form part of your collection. So here, so if you want to go back to your particular screen, you can just simply click on it and then it will route you back to that particular area. Okay? All right. So yeah, so I hope that excites you. So we're thankful na, for all the team's representation. So this is a collaborative effort. So um, with the importance of UHM, digital twin, the aims and virtual plan, it will provide us a comprehensive asset visibility and monitor the health of our equipments. We can do proactive maintenance. It will improve the way we do operations, innovate the way we do operations, and advance our technology. Also, we'll have informed decision making since we'll be getting smart insights from the system. So we'll now have smart decisions. Also, data integration. We'll be able to capture data from the different data sources and aggregating it, making it useful. Improving safety as well, since we'll be able to detect it from this model and be able to plan ahead of time. Also, cost savings. It will improve our availability, reduce our outage periods, and reduce even unplanned outage periods. And also, most importantly, it will support for our daily operations and how we do our job here in TSI. So I hope that enlightens you and you'll be able to reflect on what we've showed so far. Thank you so much.
Okay, so we're at round five. So it's now 3-2. Ready with your letters? Again, just stand up, shout your color and the letter of your answer. What are the existing platforms or data sources integrating to AIMS portal? Stand up and shout your color. E. Is it correct? Blue C. Oh. So we're now tied at 3 all. So isang A naman. Question number 10, green team, blue team, ready? What does AIM stand for? Stands for blue A, blue A, blue A already. Blue A, you already shouted A. Green. Okay. So blue A and green D. There. So it's now 4-3. That's the first answer. Asset Information Management System. So now with workstream 5, Mars.
Yeah, all right. So current standing green, blue 3. Okay, we're now down to our last speaker for today. We have, of course, our very own, one of the key users coming from TSI. All right, let's give a big hand, of course, to our very own Zan Mendoza.
So for operator rounds, I will make introduction first before the main highlight, which is our key user John. Bini John. Okay, for operator rounds, what we're gonna do basically is to transform our manual log sheet and forms to a digitalized procedure, wherein our field engineer, our maintenance technician will utilize a mobile device, a cell phone, or in TSI, a tablet, to be able to input real-time data during their usual rounds or their usual operations. And then that data will harness. So from manual log sheet, we will be manually get data and then manually input it in a Excel sheet. Here, once the field engineer or the technician will be able to log the data real time, we will be able to fetch and sync the data in our database and fetch that data and integrate it somewhere else. Where, number one, we have digital twin, we have UHM, digitalized dashboard, automated report. So there's many the possibility are endless, not endless. It still has scope and limitation, but it's better than manually storing, manually getting, manually storing, manually retrieving, and manually correlating this data to each other. So we already have GE rounds. So for Power Black. So why do we have to transition? Number one is the ease of integration to UHM, digital twin. And number two, to really to improve and customize this form for the efficiency and to really reflect the ways of working and improve the ways of working of our field engineer and technician. This will not replace them, but they this will be new ways of working for them, especially for our technician who as of now doesn't have visibility in GE rounds. So in TSI we already have GE rounds for Power Block, and we have here highlighted improvement once we transfer to Aviva operator rounds. Number one, in GE we don't have customized dashboard. But since the ease of integration, we can get that data and create customized dashboards and reports that tailor fit to the need of the end user. May it be his supervisor, RPM, the facility head, the engineering. But in the end of the day, we'll be able to fetch and use that data. Will not only be visible on our online historian data or data that coming from DCS, that coming from BCN, but data that is coming from the data that is logged from by our operator. Example are data that are currently offline, gauges that are not connected to DCS. So we can use that and relate that in a dashboard. And second, yeah, in GE APM, we can capture the equipment data. But then after where? Where is it going? So in Aviva Smart Operator Routes, we will integrate it to Twin, to UHM. And number one feature difference between Aviva and GE is that in Aviva, we can attach photos, we can attach videos, URLs that will help us more of our data gathering and analysis in the future. And one key feature is that we can mark out of service for offline data. Why is it important? Hmm, think. So why is marking out of service for offline data? Because currently, they will put zero for the data that is currently offline, in lotto, or in maintenance. But zero is still a value, right? Like for example, a drum level, zero is like 50%. So it's still a value. So for us to differentiate zero and really someone that is out of service in maintenance, in Aviva, we have a picture that we can mark it as out of service. So we, like in the digital twin presentation of ICE earlier, it's emphasized the heavily importance of our chem lab data of our coal and bed materials, right? And currently, they have a system working for them. They already have a log sheet. They convert it to Excel spreadsheet, and they already have reporting that we utilize. But once we'll enter digital twin data that we need coming from them, we will create another work process for them. So the beauty of having this data coming from rounds is really to minimize the step. From one, two, three, four rounds, we just need two steps, which is one, inputting the data in rounds, and utilizing the automatic reports and dashboard, and the integration to other platform. So for workstream 5 rounds, we will utilize management center and mobile operator. Management center is for the supervisor, for the planner, and for the key user. So I will also like to take this opportunity, marami, to highlight what is the difference of having this workstream 5 rounds to other workstream. Because this workstream 5 is heavily rely on the capability and the skills building of our key user. Who are our key user? Key users are someone from our maintenance technician, our field engineers. We're heavily, actually, the ones building the forms are not Repco. Repco are just training our key users, and they're the one building at this phase already. So at this phase, even in scope work one, our key users are really empowered to create. So they'll be able to customize already the form to really represent the current way. For example, how they do the log sheet for it to be efficient, and it has some domain knowledge inputs in making. So from the start, it's the idea is it for them to be tailored fit and for them to use it really because they have a sense of ownership. And one key factor also is on the workstream 5, we have walkthrough. So what is walkthrough that we had for CNI, RPM, Power Block, Chem Lab, and water treatment, and coal handling also, is that in this exercise, after the key user Don is building the form, he will uh, get a walk through that form with the end user, and the end user will give feedback to how to refine and improve the form. So there's a closed loop and a more of a communication and holistic approach on how we build this form. And that is one of the key improvement we have from GE to Aviva rounds. So let's take a look at the video.
A day in the life of plant operators is a blend of responsibility, technical skill, and constant vigilance. Typically, their day begins with a comprehensive shift handover where they review logs, reports, and updates from the previous shift. Shift managers sort out the prioritization of actions that need to be taken based on field and control room observations. They discuss the contents of the shift report. A shift toolbox meeting ensures smooth communication and coordination among team members working in different shifts. Conducting operator rounds during shifts is essential for maintaining the operations. These rounds allow operators to monitor equipment performance, check for any signs of wear or malfunction, and
So when
ensure
it's
that all
manual printer
systems operate
problems,
within specified
connector
parameters.
problems.
By performing regular inspections, operators can identify and address potential issues before they escalate into costly breakdowns or safety hazards. Lab results assess the water quality inside the boiler and steam turbine cycle. Results are encoded in a drive for monitoring purposes. Every end of shift, the operators and chemists prepare this report for shift turnover. The application ensures that all alarms and important notes are relayed during shift changes. Accountability is ensured as engineers are required to log into the devices before they go on with their routines. Unlike manual log sheets, this new application enables data to be monitored real time which is important in analysis and failure progression. The use of the digital device improves accuracy since data does not need to be transferred frequently. The engineers can also attach pictures as observations to the application. In immediate attention cases, this application is capable of video calls for accurate visuals of the problem. Trends are important consideration in assessing the health of a particular equipment since they could indicate impending failures. Through this new way of working, coordination and communication can certainly be improved. This function enables supervisors to check the individual parameters for alarms and possible faults. One of the key advantages of digitalization is integration. The data from this application can be fetched from the data warehouse and can be utilized to other platforms such as WorkStream 3 WHM, WorkStream 1 the Boiler Digital Twin, or even to other visualization applications such as Power BI to create dashboards and generate automatic reports.
So thank you to our unpaid actors. I think it's now time for the demo. Yeah. So it's time for the demo of how the field engineer or the technician will utilize the platform. Take over, John.
Okay, good day everyone. So to give you a quick look on what the new way of working looks like, I'm gonna give you a quick demonstration. So after you open the app, you are required to log in, and after logging in, you are greeted with this dashboard or landing page. And so first and foremost, what we need to do is to sync the data in order to fetch the most updated procedures. Okay. So after the syncing process is completed, there. Now you can now go offline. So that was one of the problems we had on our previous way of working, is that we have troubles in terms of offline use. But now we can totally work online or offline right now. So in the dashboard, we can see our scheduled procedures over here, and also we have procedures that are on demand, or these are the procedures that are always available for us. And so now, for now, let's just click on this procedures on demand. And for example, let's assign to ourselves the boiler one operator rounds. So as you can see, it's in this system, we can input your qualitative data in the form of a drop down uh, for your status lists or response lists. For example, good or poor, or high level or low level, or for the color of the filters, brown, white, black, whatever qualitative data. And let's click next. And also, of course, you can input your quantitative or your numerical data. For example, here, the steam drum level for the north side and level for the south side. So let's uh, simulate an input there. As you can see, there's the unit of measure over there, and it is linked to the specific asset that it is assigned to. Okay, so like that. Also, to give our users more information about the the health of that specific equipment or asset, we can also check the historical data that was recorded on that asset as well. And you can also see a visual graph or the trend on that to better inform the user on how to assess the situation. Okay. Now let's simulate
an abnormal reading that is beyond the limits. So for example, let's put here in the pressure for the north side, 300. The user is then prompted by a message or a warning so that they will be informed that something is wrong. And this message can also be customized to be a specific work procedure on what to do when a specific number is recorded. And for the limits, we can also assign static values for the limits, and it can also be calculated values that depends on the other parameters that you've inputted. So in this case that we have recorded an abnormal reading, we also have the functionality to add or attach files, URLs, photos, and videos to give the supervisor that we will submitting the report to more information and a, uh, a more complete picture about the situation. And of course, we can also add notes. Like for example, good luck to the next operator, or work request generated. Generated. Okay, for like that, for example. As you can see, it will show the name on who added the note. Okay, and for the case that the specific equipment or a specific gauge, for example, uh is out of service or it's isolated, so we can also click on the top right corner, that these three little dots, and click on the out of service, and it will disregard this reading parameter for the time being. This is important so that it doesn't affect our calculations of averages, because if you input 0, it will affect the average or the min max or the median of the calculations, so on and so forth. And let's simulate that we're done with the procedure. Let's just click the check and complete procedure. Yes. And it now reflects in our completed tab. And after you go back online, you can proceed to sync in order to transfer your data finally to the transfer failed. so so this is for now there is a problem because we are connected to the big screen, but this will not occur in the actual, hopefully. So so this is good because we can help our users to shorten the time they require in gathering the data, and empowering them and giving them more time to perform their actual work in assessing the situation, performing troubleshoots, and other activities that they might need to do. That's all. Thank you.
All right. Thank you so much, John. And of course, Irene. We're now down to the second to the last quiz because we have anomaly detection. Okay. There's still chance to get that 1 point ahead. Okay. Sis Mars.
Okay, for round six, but Ron has a question first.
Yeah, a couple things. Have the laptops or the tablets been spec'd? How many tablets do we need? Who's paying for the tablets? When do we need them? And who's going to do something about the Wi-Fi in the field? Because part of your presentation was that they can make calls, they can get data right away for troubleshooting. If they don't have a connection, they can't do that. So, who's paying for it all? Because it's budget season right now. Need them.
For
Is it this? Is it in 2025? And is maintenance paying for theirs? Operations paying for theirs? And who's paying for the Wi-Fi? And are the tablets spec'd?
Yeah, hi Ron. Just to supplement or answer that question. So I've been talking to the rest of the O&M teams like Sam here and then from TV as well. we're looking at a plant-wide Wi-Fi project. Although this features an offline data and then syncing when you're in a space where there's connection, right? What you wanted was when you're in the plant on site, that you'll be able to connect your and troubleshoot online. So that's something that we'll be budgeting under the IT and data management team. So, but that's for 2025, and that's a huge project, by the way. It's not just TSI; it's gonna be the rest of the plants that we, at least the bigger
Okay.
plants.
So any idea when that's going to happen?
That's next year because we're budgeting for 2025.
So it's going to be in the okay.
Yeah.
And then for the tablets, who's buying the tablets? Each department, or are you? Okay, you
Currently,
buy it.
currently it's under the project budget, Ron.
Okay, so
But
we don't have to budget for it.
no, no,
Cool, cool. All right.
already purchased. Thanks.
Yeah.
But disclaimer, will not replace tablets every year. So this is a one time. Yep. It's timely because school handling is also requesting additional ones.
That's the main concern. Okay. So guys, question 11. What do you call a collection of tasks in a given procedure for operator rounds? Color and letter. Green B.
Oh, ano blue? Anong answer?
Blue. Go blue.
Ano Jess?
Task force. C. Okay. So green B and blue C. Oh. So green B. Additional point and question number 12. How do you classify an asset as out of service? Blue D? Blue D? Blue D Canabano? Blue D. Okay. Blue D answered. Yeah. Green D as well. But blue was the first one. Click the three dots. So point, Sis Mars?
5
Oh.
green, blue 4.
Oh.
We still have anomaly.
Yeah, we have another batch, but would like to give the opportunity to our technical lead for anomaly detection to provide a quick overview about the platform. Go ahead, sir.
Okay, hello everyone. I'm Ron. Sawadee krab. Okay, so you have two more points. Please listen carefully because the answers is from my demo. Okay. So I'm gonna be doing a demo of our predictive analytics, the soon to be. So disclaimer, this is just a QA environment. So whatever you see here is not final. It's not yet properly in terms of the training data. But okay, so here's the landing page that you will see upon accessing our web page. You will see dashboards by default, the statuses of your projects, or this is the models that we have deployed in the environment. We can see the status of our cases, also the sensor health, and the overall system of this project. So by default, it is selected here the all assets, but you can also see the dashboard, for example, only for Unit 1 and only for TSI Unit 2. So from there, on the day of the life of whoever will be the end user, we will go to the alerts page. So going back to the all assets, you will have an overview of all of your models being deployed. So you can see which ones are healthy. So it has a green indicators. There's a red ones already bad. There's already warning. So later on, especially on the end user training, soon we will be explaining what's the meaning of of these colors. There's more than 3 colors that you can find. There's violet, there's blue, or whatever. So let's have an example. Let's try um, assessing this B1 boiler emissions. So you will try to analyze why is it red? So by default, again, this is what you will see first upon accessing the model. So you will see the overall model residual, which translates to the overall health of your model. So where is the model residual coming from? So as you can see here, there's more points being plotted below. So you can see, for example, stock gas NOx. What's this green? What's this gray? So remember, for anomaly detection, we are training the normal data. We are training our history for, let's say, the recommended is 6 months to 1 year data, and we will tell the machine that we will tell the AI that this is the only good ones that you should look at. So by there, from the normal data being generated, the AI will learn from it and will produce predicted values. So as you scroll through the timestamps, you will see actual value and the predicted value. So whatever so for individually for each tags, there are residuals, and the cumulative total of that residuals will translate to the overall model residual. So as you can see there, it's already currently red. So it tells us that the boiler emission model is already in bad shape. So what you can do as the end user, so you can click it here. So you can say, maybe this is just a false alert. So I just want to clear this up. So you can click clear and put some notes that this is okay. Or you have also other options, like you want to acknowledge it, pending for now, or you want to monitor it. Let's try putting it at monitor and assign to Irene. So Irene will monitor this one. So you can save. Okay. So she will now be notified about this alert, and she will monitor it. She should monitor it for any updates, for maybe diagnosis, and it will be her call as well if this should be escalated to a case, especially if it's a really big problem already. So if Irene decides that, oh, this should be a case already, so we can create a case from here. So she can create a new case, confirm, and she can put the title, like, let's just put, where's the on-screen keyboard? Let's just put test for now. Whatever. So, so there's a trends here by default that is linked for the specific alert. So let's just try for the sake of demo test. So again, you click this briefcase icon, you can see all the history, all the alerts being linked here, the closed ones, the still open ones, and let's try opening one. So we have this, the trends tab. You can also have the discussions wherein you can put any of your feedback or your diagnosis into this case. So actually, this is what I always emphasize during the reviews or the presentations. Between GE and Aviva, there's nothing much that will change with our alerts and case management. Maybe just a little adaptation to our new platform. But what's really the big um, advantage for us in the Aviva platform, as explained by Irene a while ago, is that it gives us the freedom to tailor fit our model to whatever we need and to whatever we have experienced in the past. So, yeah. And lastly, there's report generation. So you upper case, let's go back to the tab. So per case, you can generate a report to be sent to the relative parties that should investigate this one. So this is just a sample look of our report. And also we have more report types to generate. Like you can create reports for alert summary, case history, and etc. So okay. And last one, if sometimes usually we diagnose that this is already the new normal. So it should be retrained again. So again, it depends on the call of the end user. If it should be retrained, it depends on a cumulative discussion between RPM, the ops, the maintenance, the experts. if the whatever the problems we see is really bad or this is a new normal already. And that also happens currently in our workflow. It is part of our case management. Okay. So that's all for my demo. Thank you very much.
All right. So thank you, Aldi. Now for a round, I suppose we did the round three earlier. So last two questions, green team points, and then blue team 4 points, correct? Baka ma-add pa ako ng ano, dagdag bawas. Okay, question number 5. Second to the last, and there is a total deviation for all project points, which is the sum of the relative deviations for each value from the operational profile. Blue A, green, any letters? Eh, okay, so let's see what's the correct answer. Oh, oh, tie! Mahigpit na labanan, it's 5 all. Last question. If the process conditions significantly deviate from the training data and trigger false alarms by OMR, so Sis Mars, so blue B and green B, sinong nauna? Okay, blue B. Ganun ka kalaban ang blue.
Yay!
Yay!
Of course, you got prize. But you can share. Okay.
Okay.
Later daw. Sige, mag-picture kayo later.
Madami-dami, guys.
Okay. All right. So actually, we have Slido questions, but I think we can entertain like a few questions coming from the crowd. Okay. Before we go to our closing remarks, any question? We actually have prize for those who will be asking questions face to face coming from our audience. Anyone? Bukod kay aside from Ron. Who give his advanced questions. Okay, any brave soul. And then by the way, later you can experience try our screen. Okay. I think we have question in Slido.
Voluntold. I didn't ask question. Uh,
Okay.
I will ask a few questions like for example, because we will going to have a validity this coming shutdown because we have a prospective status of our boilers or boiler tubes is coming shutdown in comparison to our model. Yes. What happen if it deviates from the actual status of our boiler tubes? How will we rectify it, and how many validity are needed to say that this one is truly reliable or not?
Okay. All right. I think it's connected to model validity, the percentage.
Yes, our minimum requirement for them is overall 80% after validity. And for highly eroded area, our minimum requirement for them is 70%. So, come validation, it should be that number or greater. Currently, overall, we're okay, but on the highly eroded part, we're still at 60, around 60. So we need to improve. So how to improve? So we'll have to look on uh like simulating number one, we'd have to improve the simulation of the PSD. So before we'll just consider around 105 and we've come lower to 53 and it really improved our model. Second is to check on some area that we already discussed with maintenance if it's aligned because in the back testing we have some questionable, not all, but questionable data. And that one will have to validate during the outage. So that's another one. And if we're still not one, so we'll have to think, are we gonna add a new cluster? Like, is the startup and shutdown operating parameters have a big effect to improving that accuracy? That's number one. or do we have to look on other parameters? And we'll have to really ongoing communication and collaboration with the maintenance, because the domain knowledge of our maintenance team and our like Boss Wewe really helps on improving our accuracy for Unit 1. So for overall, we're okay, we're improving, we're already past that. And more of the highly eroded will have to improve, but we already have plans for improvement on that. And uh, some of the action item is during the outage.
Any additional thoughts from the other project teams or even the audience? If you have answer also. I hope that answer your question, sir.
Uh,
Sir Stephen.
yes, 180% is already okay.
Yeah, yeah, the overall.
Okay.
We're already good. Only that, because that's also a special request of Sir Abe. That's an input of Sir Abe during our scope of work uh, exchange with Repco, that we should also look on importance on the highly eroded area that we're monitoring, and not only look on the overall, because we will be hit hard if that's on the highly eroded area. So that's why we're also monitoring on that.
Okay, thank you so much, Sir Stephen, for that question. Any other questions from our live audience? Ayan, okay, we have another. We have a prize for you.
Okay, I posted that question in Slido as well. In the boiler digital twin, have you, because by seeing the present scenario, so we have a lot of refractory failure. So is the tool addressing that refractory wear or refractory failure? So is it being taken care?
All right, Ganesh's question is about the refractory part of the boiler.
If that's taking account on the erosion of the boiler tube, the tube leak related to erosion, or
It is being addressed by not affected, right?
so the question is if it's already integrated, or are we also monitoring the refractory, or are we monitoring the effect of or removal of refractory to the life of our boiler tube?
Not removal of refractory, just now assume wear of refractory. During this outage also, na seal part we had seen lot of refractory wear and then lot of refractory failure. So is it being addressed by our tool? Basically refractory wear and refractory failure. So are we
The erosion on the refractory.
erosion and maybe any prediction on the refractory is going to fail?
Uh, Hello, Ganesh. Regarding refractory, unfortunately, that's
Hello.
check. Check. Hello.
That's the limitation of our twin. It's more focused on the boiler tube leak to erosion, but it also consider example if we have refractory gun, how will affect the boiler tube leak, but not mismo on the refractory health. Actually, we're really damage as a challenge and come outage, we actually have a plan to get more data of the material of our refractory, for us to get more data, and later on plan on also including that or other improvements. But now our plan for outage is to get much data on our refractory. So one is to get the refractory damage, and we'll give it to Repco for analysis and for other data for our refractory.
Well, what are we going to do about backpass tubes? They aren't. Right now, it's just the yellow area that's part of this, right? Well, what are we going to do with the backpass tubes? Because that's going to be our next sore point. We're getting with the exception of this recent failure, we're getting the erosion under control. Now the life of the backpass, I think we're going to start having tube failures back there. So what's the plans?
I'll jump in and answer that. So, when we decided to do the digital twin, we did the high risk part first, and then we'll be moving on to the other sections of the boiler as we move along.
Okay, that's what I figured.
Yeah, that's not well. At the end of scope of work one, we're not done. So it's like a continuous improvement. We'll go after the next highest risk, the back pass, and then yeah.
Yes, Miss Cha.
Another question from Miss Cha.
Okay. I'm just interested of the what would be the action or the steps to be taken if there will be a new normal parameter limits. Let's say for the PSD, that is not in the 7 clusters identified. So because we know that the unit now is running for let's say 9 years, and um, based on the trend, and based also there are yes, yes, and based on the trend, example for the bottom ash, the and sand, the OEM specification is 150 to 300, but using this tabang coal, the 150 is not good now in the unit, as this is was observed in the unit 2. It causes tube leak. So this is there is already the change of parameters.
Yeah. So basically, what we really monitor now is the D50, right? As long as it's in OEM prescriptive, the standard of OEM, we're good, right? But anong good, right? Ngayon, nakita na natin, we have seen it the effect that monitoring D50 is not enough. So Com Digital Twin will not only see the D50, but also the distribution in percentage per PSD. Because because in simulation or in our digital twin also, it's not looking on a D50 median average, but in every PSD. So you'll be able to see or have a visual representation if we keep on operating uh, 300 PSD and 105 or lower PSD. When you see it in a D50, it's still median, it's still 150, right? But you'll be able to visualize the difference come its PSD is distributed across compared to highly 300 and highly 105 combination. So we already have that data, but with Twin, we have more visibility of the effect of that data. So added monitoring will not only look on the D50, we also gonna look on the per PSD equivalent percentage contribution to the D50.
The question is, yeah, we have that historical data for that PSD values before, but if what if for the current operation there will be a it's not working anymore, or there's a change, so it's not it's not we're expecting that it will tube leak based on the current, but it didn't happen, or it happened, like that.
So one will simulate again.
What is the steps to be taken when there will be addition of clusters, right?
Yeah.
What will be the steps?
So step daw, you want to first you need least what is asked is 10 days of data or 10 days and all uh on all loads profile. So 150, it should cover all of that. And then we'll get that data and then we'll ask Repco to analyze and then integrate it back to our model.
Performance test. Oh,
Yeah, we'll be able to test, and if it's a it's it will create a new cluster. Not all new changes will create a new cluster, but if it will, that's the step. But if it's not, then we're still good. We can still use our model, and doesn't need uh development. So it doesn't really say that if it's a new data, automatically we're gonna retrain, add new cluster. Only if it will create a new cluster, or if the system doesn't recognize that cluster,
that operating.
that operating mode.
Sorry. Ay, sige. Okay. Question. What if the let's say the cluster two or the cluster two um is based on the current a same operation in the cluster two, which is on the current operation it's not in cluster two anymore. It's considered as high or in cluster seven.
So your different PS particle size.
Different PSD.
Not only in PST but all the cluster there's a change in cluster. So for example, say the parameters identified in cluster two before same parameters but it's not one it's on the current performance it's not low but it's in high it's high kuna makonsider siya as high cluster. So bali there's a change of cluster with with the same parameters of the previous cluster, but on current it changed. Okay, in and right. Um, for example, so di ba you have the identified parameters and you identify the clusters. So that was on historical data. And on the current operation or performance, that same parameters, the same parameters, the current performance is not dili na siya nag-reflect sa sa cluster 2. Let's say na change siya into high cluster.
Yeah.
But same parameters. Pero dili na siya
So it's like same cluster ma'am but the different
Yeah.
load for that period RGB.
It's a
Okay, maybe sabi nga ni Josel, assignment.
uh the
Okay, we
clusters are
will take
made
note
by
of that question by the way.
sige. The clusters are made by range. So not it's not on the type of pole, but on the GCV. And the PSD, it it's on 7 cluster. It's like have to simulate all PSD for all cluster. So all PSD will cover all cluster, even it's in high, low. So PSD is not really related on the cluster, but we will simulate that PSD of for all cluster. Nag-make sense ko. Nag-make sense ko.
Simulation.
Okay. Yeah.
Okay.
Unanswered
Yeah.
lahat.
Yeah. Oh, what a way to end the question and answer. Thank you so much, Ms. Cha, for that question. We appreciate the questions. Okay. But we will take note of that. I think the work stream one, all of your questions are about work stream one, huh? We're going to take note those questions and get back to you with a detailed information about it. All right. So, as we come to the end of today's event, alam ko gutom na din po kayo. Let me first introduce, of course, Sir JP for our closing remarks. All right, and then photo off tayo later.
Okay, may hapon sa tanan. Okay. So, last question there. So, how do you feel? So, excited? Anxious? Unsa man? Okay. So, by the way, it's very important to to be open if we need relevant clarity. So, at least our project team here can help. So, please don't hesitate to reach out to them. And also, thank you for the project team for the hard work, dedication, and the contribution to this the roadshow. And for the individual milestones, for the workstream zero, for the completion of the network and cyber security requirements, including the infrastructure setup of the servers. So workstream zero, so please stand up. So round of applause for them. So, mao ni ato work stream zero ha. Patanawa sila sa inyo ha. Kuan, well, pakita mo kagwapo. Uy. Sige. So, at least about the work stream zero is the infrastructure. Kata. So, for work stream 1, for the completion of the sprint 1, 2, and 3 up to the back testing. So, where is work stream 1? Okay. Thank you so much. And for work stream 2, the completion of the model development for boiler and STG templates. Where's work stream 2, by the way? Okay. For work stream 3, the UHM installation on QA server and sprint 3 configuration. Jeremiah. Jo, come on, Jo. Okay. And for work stream 4, the completion of the application enhancements and ready for integration for AIMS portal. So, and lastly, for the technical work stream, so the completion of the key users training. So where's work stream 5? So, okay. So actually daghan ang work stream 5 diri kay ang operations diha po diri. Okay. So, and by the way, we have still work to do no for up to the go live of this project Arkanghel. So we would like to encourage the project team to continue the inspiration for the successful completion of this project, and also for everyone else. So this is for the thermal. So let's continue to support for this project. And by the way, before we end this program, so if kung kinsa to ang gusto mo try sa diri sa 3D model, so pwede ta mo kuan diri. Mura ni siya kuan ba? Ayaw gid mo kahadlok. Manam tang tanak ko, how do you feel? Do not be afraid. This is just like the evolution of the cell phones, di ba? Mingon nga ways of working. So before we travel, we bring map, we bring compass, we bring flashlight, we bring dictionary, we bring unsa pa, di ba? Nya asam na karon ang new way of working na to. Nasa to bulsa, daraw, di ba? So do not be afraid. We can do it. Thank you.
All right. Okay. So thank you all once again for being here and for making this memorable experience together. We hope you stay connected and continue the conversations at one team. So maraming salamat po. But before we end the session, would like to invite everyone for a group photo, of course, together with our project teams. Dito na lang sa harap.
After the photo op, then I guess we could try the touch screen and the snacks. We could also try that. Burn na lang natin. Ano ba siya? Go guys, let's go in front so that we could already try the snacks after. Guys, at the center, later na po yung sa gilid. Gle, I need your help. Sa center po.
Come on, guys.
Center, center.
Center, yeah.
Later na po tayo sa gilid, guys. Thank you.
Come here. Okay po.
Hoy, center. Others can, ano na lang, can do squat. Center, guys, please. Thank you. Team. Later, guys, we'll open the buffet table. Nay mo.
Guys, compress.
Guys, yung may okay pa na tuhod, we can also squat in front. Oo, so age matters. Pasok, Kle. 0.6. Sorry, Samsung. Samsung.
118. 2, 3, 118.
Guys, hold on. Let's have a video. Let's all say we are Project Arkanghel, please. Practice. 1, 2, 3. Okay, one more time. Closer. Wala na si Yal. Center. Sige, 1, 2, 3. Go. Thank you so much for your cooperation and patience. And congratulations to the Technical Roadshow team. So you can now take your snacks, guys. Thank you very much.